didn't make copies of this, but it's just kind of a warm-up just to kind of like remind you absolute value, just like really, it is picky, like with negatives and where negatives can be and that sort of thing. So let's just kind of go through this together. Is that zoomed? I can zoom in more. About 150, okay? So how many possible solutions just from looking at what you have? So the first one, absolute value of 3x plus 4 equals 5. How many solutions are you going to have? 2. 2 solutions, okay? You should split that and solve, and you can have possibility of 2. Okay, what about absolute value?
0.
Equals, why is it 0? Because it's none, no solution. Can't have that, okay? Save yourself the time. If you isolate your absolute value and there is a negative number, it's no solution, like, period. Now, if you start putting an x on the other side, like this third one, how many possible solutions could we have here?
Is it 1 or 2? I don't know.
It's 0, 1, or 2. You could have, you would solve for 2, no matter what.
Yeah.
You can't look at that and know. But you would solve for 2, but there's a possibility that they both work. There's a possibility that only one works. There is still a possibility that none of them work. Okay?
So with the first one, there has to be 2?
If it is equal to a, whoa, I don't know what I just said. If it's equal to a constant, it's either going to be they both work or they both don't. When it's the one solution is when you start putting variables on that side. Yeah.
So you would just do the exact same thing for like the third one that you would for the top one? Like that you would make the other sign negative?
But you would have to negate the x and the 5. And then checking is going to be important. What about absolute value equal to 0? It's only going to be 1. Okay? With those. Absolute value can equal 0. The problem is when, we can have a distance of 0. The problem is when absolute value is negative. Okay, true or false? Absolute value of 13 equals absolute value of 13. True. What about this one? True. What about this one? True. Next. True. True. False. False. True. Okay. What does it mean when a solution is extraneous?
It's pretty goofy.
Okay, it's the solution doesn't work in the original. You may find that solution algebraically when you do your split because you have to get 2 different equations. So you should be finding 2 x's. You just may not be keeping 2 x's. So the CFU we're about to do, it's 4 questions long. It's on paper. I want you to, on paper, get your work, circle your answers. You are going to turn the paper into me, but I did make a little Delta Math test for you to put your answers in and just see really quickly how you did. And then I'll look at the paper and see what your mistakes were. So if you get an extraneous solution or 2 or whatever in Delta Math, just like with the homework, you only input the solutions that actually work. So if you solve for 2 things and one works and one doesn't, in Delta Math, just put the one that works. But on your paper, I have to see the one that didn't work. Does that make sense? So it's just at least if you put your answers in quickly, you'll kind of know hey, I'm getting this. If you make a 0 out of 4, hey, I don't get this, so what should I do? What should you do if you don't get something? Maybe it's tutorials. Hello. Okay. So that's what we're going to do there. So have your Chromebooks out. I want you to have them closed until you're done working the assignment and then open them up and input your answer. So plan for today. We are going to learn absolute value inequalities. We have learned almost everything we need to in this unit. The last thing we have to do is inequalities. It is similar to equations. So there's, 7 or 8 questions in here. I'm going to skip a few just for time purposes. I'm going to try to just hit the high points. I will work out everything on the answer key and put it on Canvas. But I'm going to skip some problems here so that way you have some time to work on your Delta Math. Next class, we are going to take a CFU again over inequalities. And then it's just review day. So we'll be able to kind of put everything together. I will show you the answer key to the CFU you just took and let you kind of see how you did. And then we have an inequalities one. And then remember, your test is coming up next week. I don't know if this is really going to change anything that you see, but just so you know, the topics, the way they are listed on the test is not the order that we taught them in. So that was kind of annoying to me. So just FYI, they are, that's how the test is laid out. Probably not a problem for you. But anyways, that's what we're doing. You should be, right now, you should be at 67% on Delta Math. If you're not, you're behind. And then by the end of, the next time that I see you, you should be at 100% on Delta Math, okay? And then that way, next class can be focused on our check for understandings, fix mistakes we made then, and then work on the test review. Again, those CFUs are a really good indicator of what that test topic will be like. And we haven't seen transformations for a little while, so don't sleep on those because those are going to be there too. Okay, so what's different about the last class versus this class is today we're solving absolute value inequalities. So last class, everything we looked at were equations. We would get a solution like x equals 5. Okay, that's the one value. You might have had another one, but that's the one place that would make that solution true. Today, we're going to have inequality symbols. Remember, inequalities are less than or equal to, greater than or equal to. You're going to see those in place of the equal sign. But there's something that you got to consider when you have an answer that's an equation like this versus an inequality like this. How many numbers are less than 5?
Infinity.
A lot, okay?
Infinity.
So what are some examples of numbers that are less than 5?
4.
4. Negative 1,200,000 and whatever you just said. 3, 2, a lot of things. So what we'll do is in addition to writing, this is my solution set, we'll put it on a number line and we'll say this is an Algebra 1 review. We'll say our solutions happen at 5, but since it's just less than 5, what kind of circle would I put above that? Open circle. And then if I want to represent all the numbers less than 5, then I'm going to draw an arrow to the left. So you'll see on all of your problems today, you're going to have an inequality, and then there's going to be a number line. So there's kind of like a little more that you have to do when it comes to solving these. You're going to get an inequality solution, and then you're going to graph that solution on the number line. I don't know that Delta Math has number lines or not. But you definitely will on your test. So we need to make sure that we know that there. Okay, so while we're warming our brains up to this, let's look at this statement here. So this is all my extra notes right here. All right, absolute value of x is what? What does that sign say? Greater than or equal to 5. So what values make this true? I kind of like to think like in words, what am I looking for? I'm looking for when. What's absolute value by definition? What's the definition of absolute? Distance from 0. So when is the distance greater than or equal to 5? This is in words what I'm answering, okay? So I got to go to where exactly my distance is 5. And we talked about this 2 classes ago. How many places is the distance from 0, 5 exactly? 2. At 5. So I'm going to put a circle right there. And negative 5, circle right there. Am I able to fill in the circles on this one?
Yes.
Why? Greater than or equal to. So if you have that or equal to, extra ink to draw the line, extra ink to color in the circles. Okay? And then I want to know which way, where is the distance greater than or equal to 5? So where do I go from there? Distance is exactly 5 right here. Where's it going to be greater than 5? To the right or to the left?
To the right.
To the right. Okay, so I can be anything from there on. Is there anywhere else? Less than negative 5. Okay, that distance is going to be bigger as well. So I've got 2 different intervals that I can be greater than or equal to 5. So that's how I would graph that. Here's how you would write your solution sets for that. So I could say that it's x values that are less than or equal to negative 5. That takes care of this little guy. Okay, negative 5 to the left. Or it could also happen if x is what? greater than or equal to positive 5. So this would be like both parts of your answers. Of course, we'll get this from the algebra, and then we'll put it on the number line. But you have like this is your solution set, and then this is the graph of your solution set. And then the other type of problem we're going to look at right now is absolute value is less than 5. So in words, what are we looking for? When is the distance what? From 0 less than 5. Not less than or equal to, just less than 5. So where am I going to put my circles on this guy? Open circles at -5 and +5. But why are they open?
Because it's less than.
I just want, okay,
It's
not equal to. So how do I graph this?
If the numbers, the arrows going in.
The arrows are going towards each other, and they're not going to like overlap. So you're just going to connect these two. Okay? Just connect them like that. So the way that I would write this with an inequality, there's two ways. I'm going to show you one way that I would start, and then one way that you're going to have to type in Delta Math because Delta Math doesn't have an and button. So there's two possibilities. This graph is x is greater than -5 and x is less than +5. Okay? Notice the difference in the word. The other way, you can't type this in Delta Math. You cannot type and. Okay? And there's not a button for it. I don't know. I can't figure it out. I had enough. So here's how we're going to write that. We're going to write this as one compound inequality. So I can look at my lower boundary. It's kind of like a little miniature domain in inequality notation. My lower boundary is at -5, less than x, less than +5. So you put your lower boundary, your upper boundary, and you use less thans there. This is how you would have to type it in Delta Math. And for you to get those questions right, if you get one of these, you're going to have to know how to type it that way. Okay? I would accept either on a test, but I like to kind of write it with the and then go to here. And it helps with the number line too. Okay, so I underlined those words right here. I want you to understand why the word is or and why the word is and. Okay, how many graphs are matching with the word or? 2. There's 2 places it can be. It can be in this guy or it can be in this guy. So it's this interval or this interval. And then with this graph, how many graphs are on my number line?
1.
Just 1. Both of those inequalities have to be true. You have to be true in this one and this one. So that's kind of the difference between the two. But you can also get an idea from the inequality sign that is used when the absolute value is isolated. Okay, so let's go back to this one, the or one. You could, yeah, Delta Math has an or button, but they don't have an and. I don't know. I just paid $100 to renew Delta Math, and they can't even give me an and button. My money, just so you know. So no complaint about Delta Math, because, yeah. So look at this symbol right here. This might help you know if it's an or an and problem. Remember, ors go out, okay? Ands come together. So this symbol right here, what is it? The one I just circled. That's a, okay, that's a, it doesn't have that button though.
That is a great one.
That's a greater than. All right, I'm going to write it. I'm going to spell it wrong. Don't get mad, English teachers. Greater than. Okay? And then with this one, this was an and. And how would you describe this circle right, or the symbol I just circled right here?
Alligator.
No. Less than.
Oh my goodness.
Mind blowing. I know. Okay? It just gives you a, we don't see alligator anymore. We've graduated from that. Okay, you gotta know which one.
That's how I memorize it. That's how I
it.
know when I look at a problem and try to read it. It's the alligator reading.
We gotta know which one is which. Okay, so let's go to number 1. These are very similar steps to solving these. I'm gonna write some steps over here in this space. Steps. Again, we're gonna skip some of these, but here's our steps. Okay, they're very similar to how you dealt with the equations, but there are a couple things you have to be careful about with inequalities. Number 1 is we always have to get that absolute value isolated. That is not changing. You can do our B substitution thing, that we did with equations, but you got to get that absolute value all by itself, preferably on the left-hand side, okay? So we have to isolate absolute value. I'm going to abbreviate again, okay? One thing that you're going to have to be careful about, let me make sure I didn't skip any of those. What is that special rule with inequalities that happens if you multiply or divide by a certain type of number?
If you multiply or divide by a negative number, you have to flip the sign.
Very good. Beware. If you multiply or divide, so if you're isolating, you divide both sides by a negative number, the inequality flips. You might not be able to skip as many as I thought because I need to make sure we try one of those. So that's going to be in your isolating. If you're trying to get the absolute value all by itself and you have to divide over a -2, your original guy is going to flip over because that's how inequalities work. So we got to be really, really careful to make sure we don't miss that. So there's a chance you could flip and you're isolating. The other thing we do after you get that absolute value isolated, you're kind of checking. Negatives means something weird's going to happen, and we'll see one of those. So if you get a negative number all by itself, it's going to be a special case. We'll get there. But then after that, you are going to split and solve these just like we did with equations. You're going to split one side and keep everything the exact same. The other side is going to have negative on the expression, but you also have to flip the inequality as well. It's a double flip. So write it and then let me show you. So we're going to split into two linear inequalities. I'm going to abbreviate that. And I'm going to write double flip. Double flip on the right side. So just how you would write it down, and then I'll show you what I mean, but just how we would do with the equations, where we'd keep the left side identical, the right side we'd make the guy that wasn't in the absolute value bars negative, but in addition, we also have to make that inequality flip over. So you could potentially flip an inequality sign twice if you do it in step 1 or step 2, okay? And I'll try to show you one, all right? And then step 3, we are going to have to still check your solutions, and you're also going to have to graph. So similar but different, okay? I don't know that we're going to get crazy town with the fractions today. The ones I'm looking at don't look too terrible, so I'll cut you a break on that. But we do got to get through these problems here, okay? All right, number 1. Do we need to isolate our absolute value bars? No, it's already there. So I don't have to worry about anything in step number 1. This guy's positive, so we're okay. All right, negatives we'll see in a minute. So I'm good to go to step 2. So here's what I mean by that double flip. I'm still doing my 2 separate inequalities. The left one is going to be the exact same, 2x minus 5 greater than 17. Here's what I mean by double flip. 2x minus 5 stays the same. Flip the greater than to a less than. That's flip number 1. What's flip number 2? Negative 17. Okay, that's the only thing extra that you have to do. Oh, in my original equation, since the absolute value is isolated already, I kind of make a note. Is this going to be an and or an or?
And.
The original?
Greater than.
Greater. Greater less than.
Yeah.
Oh, so it was like less.
Oh.
Yeah.
I get it.
I did the best that I could, okay? With my little tricks.
No, I thought it was like the equal
The sign,
to
not
made
like
or.
it's greater than or less.
Not
than.
like greater than or less than. I thought it was like
The sign.
the sign.
Like,
Wait,
is it a
what?
line greater
It
than
is
one?
the sign.
No, but like
No,
like
like
the
at the
equal
bottom.
to would be
Like greater than or
being
equal to.
or, and that's what you're thinking.
No. The equal to is just open circles versus closed
So
circles.
then if it's less than, then it would just be.
Yeah.
Oh.
Okay, I'm sorry. Yes, let me go back to this. It has to do with the... The equal to is only going to change open and closed circles. And hey, however it is in the original, there's no way that's going to change. If you don't have a line, you ain't going to have a line the whole time. And then vice versa. But the signs, you've got to look at when the absolute value is all by itself, which it already was. And this is a greater. Okay? I understand why y'all are confused. No worries. Okay? All right, so then I just have to go and solve these two separate linear inequalities. And then I'll talk about how to write it and how to graph it. Okay? So here we go. Step 1, add the 5. Over here, 2x greater than 17 plus 5 is 22. Divide both sides by 2. Does our sign flip when we divide by a positive 2? No. So x is greater than 11. Okay? On the other side, I'm still going to add 5 as well. So I have 2x less than negative 17 plus 5 is negative 12. I'm still dividing by positive 2. Does my sign change if I'm dividing by a positive? No. It doesn't matter what's going on over here. And this is going to be x is less than negative 6. Okay? And then what word am I going to write in between? Or. So if I have an or graph, when I graph this on the number line, my branches should be going out like this. Okay? But we've got to check. I know. Everyone's favorite thing. When it comes to checking, this is another thing that is just slightly different with inequalities. You have to check a value that is true to that inequality. So if I'm looking at x is greater than 11, am I able to check with number 11? Why not? If 11 is not greater than 11. Okay, but what is a number that's greater than 11? 12. So we have to check with something that actually fits in that. What if it was greater than or equal to? Would 11 be okay then? Yeah. I usually just kind of pick one number bigger or smaller just to be safe with that. So if I put x equals 12 in the original absolute value equation, I should be getting a true statement. Okay? Absolute value of 12. I don't know why I put that first. 2 times 12 minus 5. Is that greater than 17? That is the question we are asking. 2 times 12 is 24. 24 minus 5 is the absolute value of 19 greater than 17? Yes. So this solution does work. Okay? I'm going to graph it all in a second. On the other side, x is less than negative 6. What's something good to check here? Negative 7. Something that is true in there. 2. Hmm? What am I doing? Greater than 17. Okay, 2 times negative 7 is negative 14 minus 5 is absolute value of negative 19. Is that greater than 17?
Yes.
Yes. So this also works. So technically I should circle both. Okay, so in Delta Math, again, there's going to be a little or button. You might be able to type it. I don't know. You'll have to kind of guess around with that. I know you can't type and because I was having a fit trying to make that work. Okay, so now when we graph it, I don't need like a whole spectacular number line here. Here's kind of what I want. What's the smaller of my two numbers? So I'm going to put negative 6 right here. And what kind of circle am I going to put above that? Open. Okay. And then this is an or, so they're going to be going opposite ways. Or just read the inequality. X is less than negative 6. So where does my line go? Left or right? Left. Arrow on. And then the other side, I'm going to put positive 11. Again, I don't need all the little digits in between. I'm okay. I'm assuming y'all can order these correctly. Another open circle, they should both be open or both be closed, people. It's never going to be a 1 and 1. X is greater than 11 is going to point to the right, like that. Okay? So there's your first example. I do not think Delta Math has the number lines, but I'm telling you they're on the test. Number lines on the test are all or none. There is no partial credit. There is no excuse for missing open circles and closed circles. They've got to match what you give me as your solution set, okay? So if they're an or, they better be going this way, okay? You're going this way or you're going this way. If they're an and, they got to be in the middle, okay? Let's try, flip over. I'm trying to limit how many I make you do, but also make sure you see the different types. We got to do number 2. Got to do number 2, okay? All right, here we go. Number 2. Do we have to isolate in this situation? Yes, we do, okay? Because the absolute value is not by itself. I'm going to keep doing my let B equal thing. If you don't like this, you can still isolate without that, but I do think it is helping, especially on like that question like number 4 on your CFU. So this is 2b minus 8 less than or equal to 10. I cannot do my greater less than thing until I get absolute value alone. So hold off on that. Absolute value is not isolated here. I'm not ready to look at that yet. Okay? So I need to add 8, 2b less than or equal to 18. Divide by positive 2. Does anything change when I divide by positive 2? No, but watch out for that. There is a possibility that you could have to flip there. So I'm now looking at absolute value of x minus 1 less than or equal to 9. I am okay. I'm going to draw an arrow right here at this equation. I am okay to do my less than, greater, or greater, less than thing now because the absolute value is all by itself. I am also okay to check my solutions in this guy because this is an absolute value inequality, isn't it? So it's okay. All right, so I kind of draw in an arrow to like, I'm good to do everything from there. I would write to the side, this is a less than. So when it comes to graphing these, I should just have one line connecting my 2 endpoints. And I'm going to write a compound inequality. I'm going to show you how to do that. Okay? I'm not going to have open or closed circles. Closed. You might even like make a note of that as well. Why are they closed? Because they equal to. Okay? All right, now I'm good. And then 9 is positive. Always want to check and make sure it's positive. Weird things will happen if it's negative. We'll get there. Now I'm good to split. So my left one is just going to be x minus 1 less than or equal to positive 9. My right one, I got the double flip. X minus 1, flip the inequality, negate the number. Okay? Those of you that came in a little bit late, that's what happened there. It's a double flip. Flip the sign, flip the number. Okay? And then solve from there. And go ahead and write that word and in the middle. And I'm going to write that there as well. Okay? I still have to check. I'm going to do my checking over here because I'm running out of space. It is okay to check in where my arrow is. All right? The isolated absolute value equation. It will be easier. And honestly, all your equations can always be checked in the isolated one. You just have to make sure that you're always checking in an absolute value one. Okay? So first one, what number should we use? A number less than or equal to 10. You can use 10. I'm going to use 9. But you can use 10. Why can you use 10? Because it's or equal to. Okay, so just be careful with that. I'm going to continue to show it a different number just in case. But yeah, so this will be absolute value of 9 minus 1. Is that less than or equal to 9? The absolute value of 9 minus 1 is 8. Is 8 less than or equal to 9? True or false? This is true. So this one is going to work. So we have a check there. On the other one, greater than or equal to negative 8. Try negative 7. So the value of negative 7 minus 1 is that less than or equal to 9. absolute value of negative 8. Yes, in fact, that is less than or equal to 9. So this is my solution set. Okay, can I type this in Delta Math because of this and? No, so I'm going to rewrite it, but I'm going to do the number line first. What's the smaller of the two numbers? Negative 8. What's the larger? What kind of circles? Closed. Now, it's a less than problem. These should be pointing to each other, but let's just check. We want to be less than 10, so we're going to the left. And we want to be bigger than negative 8. These are going to be going towards each other, so are they going to connect?
Yes.
So then here's what my graph looks like. So what do you type in Delta Math?
Negative 8 and 10.
Negative 8 is less than or equal to x less than or equal to 10. You can't, this says the same thing. It's just that this doesn't have the word and then this one does. These are two equivalent. I would count the and right on your test. But if you want to get all your Delta Math right, you're going to have to type it this way. And if you look at it, like, again, I know we don't talk about alligators here, but x is less than or equal to 10. That matches this guy. This side of it, the alligator is still opening up towards the x right here and right here. So it's just a compound inequality, okay? You are going to have to know how to do this in Delta Math to get it all the way right. So make sure you kind of see how that works. Yes. Is that what you're going to ask? I will work out 3. It's not bad. It's just kind of repetitive. I will work out 4. I would suggest looking at 4, to be honest, because there is a negative sign flip thing. The 1/3 is a little bit weird, but for time purposes, we're just going to jump to number 5 and then probably do the last 2 and then call it a day. Okay?
What do you do if x is like less than 0?
Okay, that's what we're about to see on this one. So let's look at 5. Okay, here we go. Steps. Do we need to isolate our absolute value here?
Yes.
Yes, so I'm going to let b equal absolute value of x minus 1. And so I have 3 minus 4b less than or equal to 13. I'm not circling and writing less than greater yet because it's not by itself. So I got to get it by itself, okay? Subtract the 3 over. 13 minus 3 is 10. Divide by what kind of 4?
Negative.
So what has got to happen to your inequality sign because you divide by a negative? Divide by negative number, you got to flip. Flip the inequality sign is what you're flipping. So this less than or equal to is going to become a greater than or equal to. And then this number, can we reduce this? Negative 5 over 2. Okay? All right, so we had a couple important things happen here. First thing is I wanted y'all to see that you could potentially flip that inequality while you're isolating. I'm going to take back the absolute value here, and I have absolute value of x minus 1 greater than or equal to negative 5 over 2. So if you ever get a negative over here, okay, your brain needs to be going ding, 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 ding. Something is weird, okay? We can never have absolute value equal negatives. Never, ever, okay? But can we have absolute value greater than a negative?
Yeah.
When is it greater than a negative?
That's positive.
Always. All the time. Absolute value, write this down. Absolute value is always positive. So what is your answer to this? Not no solution. All solutions. This is a all or infinite solutions. Absolute value is always, always positive. Okay? Because that says absolute value is greater than a negative, and it will always be. Okay?
It's a good one because it's couldn't it like equal what negative 5 have? Right?
But it says greater than or. It's always the greater than is going to trump that.
I get it, but like if it can be equal to, right?
Mm-hmm.
So it's saying that it can be a negative, right?
I see what you're saying. But it's always... Let me think on that, how I want to explain that. Real quick here. I see what you're saying now. Real quick. We're going to play a little game. Do this to the side. Okay? It's not bad. It's not bad. Okay. What do you do if you get this? Absolute value of x minus 1 is equal to negative 5 over 2. That's a no solution. No solution. Okay? What do you do if you have absolute value of x minus 1 is less than or equal to negative 5 over 2? Is it ever going to be less than? No. So your answer is no solution. And then this one is if it's greater than. It will always be greater than. So that would be all solutions. I'm going to keep thinking on your question because I see what you're saying. But I feel like I had a good explanation for that, and it's not coming to me yet. Okay? So, again, with those negatives, you just got to be careful. And you got to be like, ding, 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 ding. Something is happening because that's a negative there. On the number line, you just graph a number line over it. Like that. Yes?
Would we be able to write all real numbers?
I'm going to get you started on 6, and you're going to finish 6. And then we'll do 7, and then if you want to do 8, I will work that one up here, and you can see that it's not too terrible. Here we go. Let me just get you started on this one. You are going to get a fraction. You're going to get a fraction on this one. It's okay. Fractions are our friends. Okay, is our absolute value isolated on number 6? We don't have to change anything. So you can circle this sign and write yourself a little note. What is this going to be? An or an and?
Or.
This is a greater. Okay? All right, what's different about this one is on that right-hand side, you now have an expression. That's okay. We're going to do the same thing that we did. We talked about this last class with equations. Here we go with inequalities. So, split 5 minus 3x greater than 9 minus 2x. On the other side, we got a double flip. 5 minus 3x, flip inequality, flip the signs, oops, that's a 2, flip the signs, all the signs, in 1 step or 2 step, you do you, and go from there. You are going to get a fractional, you're going to get a number on this one. Fraction, number, solution, that's okay. When it comes to checking, be smart about what you check. Ready, set, with inequalities. The way that I solved this was I prefer, and you should prefer, in my opinion, to always move your variable to the left-hand side. I think it makes it a lot easier to read the inequality if it's x is something, a number. So even though moving these variables over here gave me negative coefficients, that's okay. I can divide by negatives. I got to be careful, though, when I divide by negatives, because what do I have to do to my inequalities?
Flip.
I have to flip them. So you're flipping your inequalities like several times in this problem, okay? But again, when it comes to like reading what this says and putting it on a number line, I think it's easier to put your x on the left, and then now I know what to check from there. You want to be smart about what you check, okay? So with this 14 over 5, yes, that looks gross. 14 over 5, ew. But I need to check with a number that is greater than 14 over 5. So I chose 15 over 5. And what is 15 over 5? 3. So I checked with a 3. And then I was able to get that both of these work on your number line. So here is your solution set. You type it like that in Delta Math. Okay? On your number line, I'm going to put the smaller number first, -4, with a open circle pointing to the left. Or over here, 14 over 5 is bigger. Open circle pointing to the right.
I'm so annoyed.
Why are we annoyed?
Because I did it wrong and now I said.
All right, I understand if you guys want to like work on number 8, and again, I will. I'll leave the camera up and I'll work number 8. Number 7 though, this one, both these are kind of weird. Okay, 7 and 8. I know 8 looks scary because of the fraction, but it's not that bad. Number 7, you are going to get a solution that does not work on number 7. We haven't seen that yet. It's not as common with inequalities, but it is a possibility. So the first thing that I would do here is, what side do I always like my absolute value to be on? I always like my absolute value to be on the left. So the first thing I'm going to do is just completely flip-flop this inequality. But if I do that, though, what do I have to do with this sign? I got to flip it. That's just how I like it to be set up from there. And then I have to do my split. I don't have to isolate anything, but now I have to do my split with my double flip. Okay, 2x minus 12
Double flip.
less than, oh, what am I going to have here? Well, you're only going to have one solution, but let's go ahead and just make note about it. This is a less than. Unless it doesn't work, hint, hint, that's what's going to happen. So this is 7x plus 3. Over here, I have 2x minus 12, flip, and negate. But double flip sounds better. And then I can solve from here. Are we okay? Y'all with me? All right, I'm moving to the left because I like that better. 2x minus 7x. Negative 5x. Okay? And then I'm going to go ahead in the same step and add the 12. 12 plus 3 is 15. And then I'm dividing by negative 5. So what happens because I'm dividing by a negative? We flip it back. And this becomes a negative 3. Okay? Over here, I got to distribute in that minus sign. I'm going to move over here. This will give me 9x. Add over here, negative 3 plus 12. Y'all good?
No.
Why did I what? Did I do it right?
Why did you flip it back?
What do you mean flip it back?
Oh, never mind.
My math is right?
Yeah.
That's what I had on my paper from last year, but I just never know. Okay, what do you notice about both of these signs, first of all?
That they're the same.
That they're the same. Okay, so it has to be true for both of these. This is an and problem. So theoretically, one of them is not going to work because they both are the same sign. If you go back and check, this one is going to be extraneous. Okay, if it has to be greater than negative 3 and greater than negative 1. For those both to be true, you have to start when x is 1. The only way for it to be greater than both of them and both be true is it's going to be pointing this way. But I'll show you. I'll plug in a value and you'll see why this one does not work. Okay? And so you only get one answer there. I don't foresee that happening on Delta Math. I haven't seen it so far. But it is a possibility, so we're showing you. But again, the checking is really important with that. So I'll check it up here. We'll check with negative 2. 2 times negative 2 minus 12 in the absolute value bars less than 7 times negative 2 plus 3. 2 times negative 2 is negative 4 minus 12 is 14. Right?
What? No, so negative 16.
16. Thank you. And then 7 times negative 2. Okay, that's negative 14. Negative 14 plus 3 is... So this says 16. The absolute value of negative 16 is 16. This says 16 is less than negative 11. Is that true or false? That is incorrect. So this is an extraneous solution, and this is your only solution. I will check this one too. Okay? Number 8, you just get one solution, but it's not... You get the same inequality on both sides of the thing, so it's kind of weird. So I will work that one. The ones that I skipped, again, I'm going to put on the answer key in Canvas. Hold your thought real quick. Just so you know, Delta Math needs to be at, you are able to get 100% of Delta Math done. I know we don't have a ton of time, but we need to make sure that we do that. I don't think it's a whole lot of problems. How many is it? 5? 5. 5 problems. You're going to do a CFU over inequalities next time and review day, but your Delta Math needs to be at 100%. Okay?